So what first got me interested in actors was I didn't know that's what I actually needed when I first started looking for it. I was trying to build a real-time marketing automation system on top of a real-time analytics product I had built on top of ASP.NET and Cassandra. And I didn't realize at the time, but what I was really trying to build was a real-time stream processing architecture, which requires you to keep state and memory. After enough creative Googling, I eventually stumbled on the Akka framework and realized what I need is an actor. And that's what really got me into it, was I had a product deadline I had to hit for a startup that was running out of cash. And I just went down the road of trying to get that concept implemented in .NET as quickly as I could. Spent 2 weeks evaluating, trying to port a bunch of our middleware and other pieces of technology that all of our microservices used at this company onto Java. I actually went ahead and got Eclipse installed and got my system set up and started getting the Scala tools in place, and spent a couple of weeks porting a very simple piece of middleware we had over to Java. Because the thing I had to think about was, okay, well, I might be doing some of this, but I also have a team of developers who have to not only be able to develop against it, but also figure out how to do deployments, orchestration, monitoring, etc. And ultimately, I came to the conclusion that the costs of doing that, of trying to port our business over to a new platform, at least even just for that one service, given the scale that we were operating at, I mean, we're doing hundreds of millions of transactions a day, I thought it was too risky to do that, given that none of us had any operational experience in anything other than .NET and Windows. So we decided to go ahead and pick the lesser of two evils and port an actor framework to .NET, is what we did. Yeah. So no good options, but I think we made the right call. I think one of the most valuable metrics for any sort of framework or development tool at all is, I call it time in production, which is how much time has this technology spent being ground to bits by actual production use. And that accumulates over time. So if you have a library being deployed on 10,000 applications, all running concurrently 365 days a year, that's gonna go ahead and acquire 10,000 years of production time in one calendar year. Akka had been around for, I think, this is 2013 when I started working on this, so it would have been about 4 years. So it had a lot of time in production. It was already being used inside Apache Spark by then, the very early versions of it and everything else. And so I figured, rather than invent my own way of doing things, why not borrow the ideas that have already been battle tested, even on another platform, and learn from their mistakes and their successes too, rather than try and invent something new from scratch. Petabridge is an organization dedicated to maintaining Akka.NET, but also supporting it commercially. And so I spend pretty much all day working on it. We have some other open source technologies that aren't Akka.NET that we work on, like NBench, which is a performance testing framework, but Akka.NET's like 99% of what we do. These days, I don't get as much time to contribute directly to the source code as I would like. I spend much more time working directly with customers who are adopting it. So types of users who end up using Akka.NET, a lot of real-time sort of finance applications, lots of folks working in industries like advertising, marketing, automation, analytics, lots of IoT. In particular, you see a lot of IoT usage in industries like logistics, where they're keeping track of things like packages that are being shipped, or RFID containers in warehouses. Transportation's another one, keeping track of fleets of vehicles. So far we've had buses, planes, trains, satellites, and boats. So we haven't done anything like drones yet. That'll be the next type of vehicle I guess we get to track. So working on that next. We try to follow it pretty closely. One of the big advantages of having Akka available on .NET and on the JVM is that people switch jobs. And so if I'm a professional Scala developer and I want to change and I go into an organization that's primarily .NET, well, if I recognize a problem that looks like something that would be amenable to the actor model, being able to go ahead and just pick up the exact same sets of APIs I know how to use, even if the syntax and the runtime is different, I can go ahead and fall right back into the same patterns and everything else and bring the institutionalized knowledge with me to multiple environments, which there's a lot of inherent value in that. We've even seen some cross-pollination where Akka.NET developers get JVM jobs, and now they go ahead and pick up the original Scala-based Akka. We do have some implementations that we've made that are fairly original because there's some differences in the way the end users use the platform. So for instance, .NET is very heavy on dependency injection, so we're in the process of writing a fairly novel way of transparently weaving DI in with the way props and other parts of Akka work. That's something that you won't normally find on the JVM. And there's other little bits of innovation here and there. Sometimes we release their beta features before they do. Just really depends on the development cycle. We did that most recently in our 1.2 patch. We released a feature that I wrote called Coordinated Shutdown, which was still in beta on the JVM. I didn't realize that at the time. I assumed it was already available and we shipped that. But we try to keep pretty close API parity. In a lot of ways, we're usually trailing them by a little bit since they're still leading the charge on a lot of the original innovation and development. Plus, Lightbend, the organization that maintains that's been around for longer. They've raised a lot of money, and they have a lot more resources to do more things faster than we do. But we'll get there. Well, I'd say the biggest advantage of Akka.NET over any other sort of active framework out there is that Akka.NET scales down much better than they do. You're not going to be able to run Orleans on a Xamarin application or inside WPF necessarily. Akka, you can just use the core actor library and use that in a very local context, whether you're building a command line app or maybe you want to use Akka to go and manage concurrent updates to a SignalR hub if you're doing ASP.NET. There's all sorts of different use cases for it that don't involve distributed computing. But if you want to take that same tool set and scale it up with you, you can start using modules like Akka.Remote, which allows communication between more than one process, Akka.Cluster, which allows you to build a network of processes, and there's even more modules like distributed data and cluster sharding that get sort of bigger and bigger from there. So it can be as big or as small as you want. On top of that, there's a lot of resources available for Akka.NET compared to those libraries in terms of being able to pick it up and start learning it. So there's lots of Pluralsight courses. There's Akka.NET Bootcamp, which has had like 20,000 developers go through it. So there's just a lot available and the community is quite large. I really wanted to see Roland, who I think has just finished speaking. So I really wanted to see his talk. I really want to see Martin Thompson, who's the developer behind Aeron and Simple Binary Encoding, speak. And then I really enjoyed the quantum computing lecture that was done this morning. That was the first time in a while I've ever sat down and listened to someone speak and be like, wow, I might be out of a job in 20 years. So that was very fascinating. This has been a brilliant conference, and I couldn't have asked for a more relaxed environment and a better group of speakers. So thank you for putting this together.